Hi, welcome to the Magic of Math, where we master math one video at a time. Today, my video lesson is on proportional relationships and slope. Our objectives today are that you will understand the relationship between proportional relationships and linear relationships, and that you will find and interpret slope of proportional relationships. You will graph proportional relationships, and you will compare proportional relationships. So it sounds like a lot, but we're going to do some review and add on to our previously learned knowledge and put it all together. Here's the question I want you to think about today. What is the relationship between slope and unit rate? All right, let's begin by going over some vocabulary. A linear relationship is a relationship that has a graph that is a straight line. So here are 4 examples of linear relationships. 4 graphs, all lines. So even though this is only one quadrant, the first quadrant, and it shows what some students would say, oh, it's only half a line, it's still a line. There's no breaks, there's no turns in it, no curves, it is a line. So these are all representing linear relationships, which you will learn about more. Now let's talk about proportional relationships, which is going to be our main focus today in this video. This is a special relationship where the graph of a linear relationship, a straight line, passes through the origin. So all proportional relationships represent a linear relationship that passes through the origin. So here are 4 linear relationships. Let's see which of them are proportional relationships. So we look to see it passes through the origin, therefore, indeed, it is a proportional relationship and a linear relationship. The second graph does not pass through the origin, therefore it is linear but not proportional. Our third graph also does not pass through the origin, so it is linear but not proportional. And our fourth and final graph passes through the origin, so changed it to pink. It is proportional and linear. So there you have it. A proportional relationship is the equation of a line that passes through the origin when you look at the graph. Now let's talk about proportional relationships, which are 2 quantities are proportional if they vary and have a constant ratio. The constant ratio is the unit rate when it is written in simplest form. So we can represent this proportional relationship using words. Here's an example. At the bakery, the cost, Y, to purchase X bagels is $2 per bagel. So I'm describing the proportional relationship in words. Now we can look at it using a table. We have our 2 quantities, our X and our Y. We're told in words that the X represents the number of bagels purchased and Y represents the total cost to purchase those X number of bagels. So bagels and dollars. So 0 bagels, $0. 1 bagel, $2. 2 bagels, $4. 3 bagels, $6. We know it's a proportional relationship because here is our origin point, 0, 0. Another way to represent a proportional relationship is by using a graph. So here we have our bagel bakery. Our y-axis represents the total cost of our expenditure, how many bagels we bought, and our x-axis is how many bagels we purchased. So you can take your table of values and plot them in your graph to have a visual representation of your proportional relationship. So let's graph this. Our ordered pair xy, 0, 0. So we plot our point at the origin. Our next point xy, 1, 2. So go over 1 to the x, up to 2 on the y, and plot a point. Our next one is when x is 2, y is 4. So go over to 2 on your x, up to 4, and plot another point. Back to our table when x is 3, y is 6. So over to 3 on my x, up to 6 on my y, and plot a point. Connect your points with a line, and there you have your graph of this proportional relationship. A fourth way that you can represent a proportional relationship is using an equation. The equation will always be written in the form y equals k times x. Again, this is for proportional relationships only. K is our constant of proportionality, which we'll review more in a minute, and it represents a ratio of any y coordinate over its x coordinate. So this is a relationship. This is a specific x and y that together make an ordered pair or a point on the line. So when I look at this, I can pick any point except the origin because we don't want to divide by 0. So here I have y to x, 2 over 1, or I could use 4 over 2, or 6 over 3. It is y over x, so dollars per bagel. So when I do that, I can see that y values here, 2, 4, 6, which you can also see in your table, 0, 2, 4, 6. So y is increasing by 2 as my x, 1, 2, 3, which also represents our table, 0, 1, 2, 3. So as y is increasing by 2, x is increasing by 1. So every 2 bagels, every $2, I can buy another bagel, which means $2 per bagel. So k is 2, and our equation, we replace this k with 2. Y equals 2 times x shows a relationship between x and y relative to the bagel bakery. Now let's talk about solutions of an equation. This is what we've brought forward from the previous slide. We have our graph that we did together of our bagel bakery, the equation of the line that we wrote, and the table of values. So the equation y equals 2x is a linear equation since the graph is a straight line. The equation of a line represents the relationship between two quantities x and y. So there's a relationship here between this x and this y. The solution of a linear equation is two values, one for each variable, that represents an ordered pair written in the form x comma y. And these are all points on the line. So an ordered pair, or a point on a line, remember a line by definition is an infinite number of points. Every one of those points is a solution to this linear equation. So when I go and I look at my ordered pairs from my table, x comma y, let's look at our first one. Our first is the origin, 0, 0. And what happens is we're going to take that ordered pair and plug it into this equation and evaluate. So y is going to be 0 when x is 0. 2 times 0, that product is 0, and it checks. So when x is 0, y is also 0, which makes this linear relationship a proportional relationship. Our second ordered pair we get from our table. When x is 1, y is 2. We're going to use this and evaluate our equation. So when y is 2, we're going to replace x with 1. The product 2 times 1 is 2, so it checks. Our next ordered pair from our table is 2, 4. And we use those values. When y is 4, x will be 2. The product 2 times 2 is 4. And our fourth ordered pair, 3, 6. When we plug in 6 for x, and we do the product, 2 times 3, we get 6. Now, that's just 4 of the solutions to this. A line has an infinite number of points. It extends infinitely in this direction. It doesn't extend infinitely in this direction because we're talking about bagels and cost, and we can't have negative dollars to spend, and we can't buy negative bagels. So, but I could keep going up in this pattern, and I can see right here I would have a point right here that intersects here, and that tells me that 4 bagels would cost $8. So when x is 4, 2 times 4 is 8. It checks. So now that I've written this equation, I could plug in any number. I could say, oh, 100 bagels. Well, I can't see 100 bagels on my graph because it ends over here at 9. But I can use my equation. If I want to buy X number of bagels, let's say it's 100, 2 times 100 would tell me my cost for 100 bagels would be $200. So this equation becomes very handy when you want to project out or find a value that is not on your graph. Now let's talk about rate of change and slope. Previously, you have learned about a ratio, and that is a comparison of two quantities. Then we add on that it becomes a rate or rate of change, which is a special ratio, and it compares different units. So miles per gallon, dollars per bagel, things like that. Now, unit rate was a rate of change written with a denominator of 1. So $2 per bagel, 60 miles per hour. So unit rate, denominator of 1. Now we introduce slope, which when we're talking about a linear relationship, is our constant rate of change. Well, constant rate of change, or slope, is a ratio of the change in y over the change in x. When we talk about a real-world problem, we have that rate of change, and it becomes a unit rate when our denominator is 1. So all of this information connects. Slope is a ratio that represents a constant rate of change, and when you consider it with a denominator of 1, it's your unit rate in a real-world problem. So all lines have a constant rate of change, which means all lines have a slope. When we have a proportional relationship, our constant rate of change, or our slope, is also our constant of proportionality. So since our bagel bakery graph, which I have brought forward, passes through or starts at the origin, we know that it's a proportional linear relationship. So it's through the origin, and it has a graph is a line, therefore it is a proportional linear relationship. Notice that the word linear has line in it. Linear means graph is a line. A proportional linear relationship has a unique slope, or constant rate of change, that we call the constant of proportionality. What makes it unique is that any ordered pair, except for the origin, on the line, ratio y to x will give you the slope or constant of proportionality. Let's look closer at this. So k is our constant of proportionality. It's just the universal variable that when you see this, you know that it's representing the constant of proportionality or slope of a proportional linear relationship. So we can take any ordered pair and write it y over x, and that gives us our k. So our first ordered pair, when y is 2, x is 1. So ratio 2 to 1. Our next ordered pair would be y to x, 4 to 2. Our third one, 6 to 3. All of these, written in simplest form, are equal to 2. So we can say that the bagel bakery charges $2 per bagel. Now let's talk about unit rate and slope. All lines have a constant rate of change, also known as slope, but we don't always refer to it as k. If the line does not pass through the origin, which this line does not, it's just to the right, the line still has a constant rate of change, and it still has a slope, but it's not k, and you can't find it in the unique fashion of y over x. It becomes the change in y over the change in x. I'm going to touch upon it briefly here, but our next video in this playlist will go into more specifics of finding slope of a line. So if I look at this and I consider all of our values, our x values, so you can see this ordered pair has an x value of 1, the second one has an x value of 2, then 3, then 4. Now let's look at our y values. Y coordinate here is 1, this one is 3, 5, 7. I think this is very helpful to make your little dots on your y-axis and on your x-axis so that you can visually see the pattern or the constant rate of change. So if I look here, I go from 1 to 3 to 5 to 7, and you can see that y values are increasing in intervals of 2. On the x-axis, it goes from 1 to 2 to 3 to 4, telling us that it's increasing by 1. So I can conclude that my constant rate of change is, as x is increasing by 1, y increases by 2. That represents, in words, my slope or constant rate of change. So here we can say that our change in y, 2, over our change in x, 1, 2 over 1, the slope is 2. So that you can see that I still have a slope of 2, but it doesn't pass through the origin. It's a different line. Let's talk about finding slope one more time. I'm actually going to say here, let's read this. All lines have a constant rate of change. To find slope, identify the ratio of the change in y to the change in x. I'm going to ask you to pause, identify the slope, and come back and hit play when you're ready to check your work. Welcome back. So once again, I'm going to understand that we're finding slope as constant rate of change because it's not a proportional relationship. It does not pass through the origin. We're going to refer to slope as the variable m. So anytime you see m in algebra, that is referring to the slope of a line. So now reviewing that our slope is going to be the change in our y over the change in our x. So let's go to our graph and we're going to identify here y4, y5, y is 6. So we're increasing by 1. Our y-axis, y is increasing by 1. Our dollars, our total cost, dollars are increasing by 1. Let's see what's happening on the x. So 3, we drop down, there's our 3. X is 6, x is 9. So we can see 3, 6, 9 is increasing by 3. So as our change in y is 1 over our change in x of 3, the slope of this line, this linear relationship, is 1/3. Again, this is not a proportional linear relationship because it does not pass through the origin, but it still is a constant rate of change, which is our slope, and it's a ratio of 1:3. Now, let's interpret our slope. When you are asked to interpret slope, the expectation is for you to use words to explain what the slope means to the context of the problem. So you're going to use your title and your labels of your axes to do this for you. So we know that this is a ratio of y to x. So our change in y over our change in x. So we go back to our title. The bagel bakery costs $1, right? Y for 3 bagels. So that's what that means. So our change in y over our change in x, $1 for 3 bagels. And we can then go further and say our unit rate, when we simplify this to have a denominator of 1 divided by 3 is 0.3 repeating, but it's money. So we're going to write it to the nearest hundredth and say that the bagel bakery charges 33 cents per bagel. So students often want to say, well, the larger number is going to be the numerator because this is 1, it has to be the denominator. That doesn't work that way. Let the graph tell you. Our y is increasing by 1, so positive 1, as our x is increasing by 3. So y over x, 1 over 3, simplify. 1 divided by 3 gives us 33 cents per bagel. Also our unit rate, also our slope, or our constant rate of change. All right, let's go over graphing an equation. We have the cost y in dollars of purchasing computer stickers. X is a proportional relationship. Then this tells us that our line will pass through the origin. This can be represented by the equation y equals 4x. Again, understanding this 4 represents our constant proportionality k, which is also our constant rate of change or slope, our ratio of y over x. We're going to graph the equation and we're going to find and interpret the slope. So to graph the equation, our first task, let's set up our graph. We're going to title it computer stickers because we're purchasing computer stickers. Our y right here tells us in the problem is dollars, so let's label our y-axis and our x. So our x is the number of stickers we buy, and our y-axis is the number of dollars that we spend buying X number of stickers. So now to graph this equation, we're going to create a table of values, and we are going to put in any values of X we want. So we can start with 0, 1, and 2. You could have put in 4, 5, 6. You could put in 100, 200, 300. That would make your graph really big though. You could even put in 1/2, but I don't want to put in 1/2 because that doesn't make any sense because I'm not going to buy half of a sticker. You can only buy a whole sticker. So when we go to find out what the y value is when x is 0, we're going to go up here to our equation because we know that y is going to be equal to 4 times the x value. 4 times 0 is 0. So now we have one ordered pair we can plot on our graph, 0, 0. So we plot a point at the origin. Now we go back up to our equation. When x is 1, 4 times 1 is 4. So now we have a second ordered pair. X is 1, y is 4, plot our point. And now when x is 2, going back up to the equation, 4 times 2 is 8. So plot our points, 2, 8. And now we can connect our points, our ordered pairs, with our straight line. And there you have the linear relationship, which is also a proportional relationship. Our graph is a line that passes through the origin. So now that we've graphed the equation, we're also asked to find and interpret the slope. So let's go back to the strategy I showed you earlier. Let's go and put our y coordinates so we can see our change in y. So here's our 4. We're going to go up an 8. So we go 4, 4. So 0, 4, 8. We're increasing by 4. So our change in y is 4. Our change in x, 1, 2, is 1. 0, 1, 2. So as y increases by 4, x is increasing by 1. So we have a slope, which is also could be k here, 4 over 1, which is that telling us that $4 per sticker. So computer stickers cost $4 per sticker. Again, going back here, because it is a proportional relationship, any ordered pair will also give me that ratio. 4 divided by 1 is 4. 8 divided by 2 is 4. But this other strategy I gave you works for any linear relationship. The one of doing y over x from the ordered pairs only works if it's proportional. Now, let's talk about comparing relationships. So we have represented a linear relationship in 4 ways. We have used a table, an equation, a graph, and with words. We can use what we know about each of these relationships to compare 2 different relationships. So here are 2 different relationships. Last weekend, 2 movies were released in theaters. The first movie we'll call movie A had sales that are represented by the equation y equals 1.8x, where y represents the total sales in millions of dollars and x represents the number of tickets sold in thousands. The second movie, we'll call movie B, had sales that are represented by the graph. And we are asked which movie had the greatest amount of sales and be able to explain. So before I set you free, reminding you, you have movie A that's represented by an equation, and then movie B represented by a graph. So I'm going to ask you to pause and determine which movie had the greatest amount of sales and explain why. Welcome back. So here's our solution. Let's first talk about movie A, where we see that it's represented by this equation. So we can look at our unit rate or our slope, our constant proportionality that comes before the x in the equation. So that tells us that movie A made 1,800,000 per day. So this was given to us in millions. So that 1.8 is not $1.80 because it said it was in millions of dollars. So we have to extend this out and write this as 1.8 million, which was 1,800,000. So in one day, or in each day, that's how much money it made. Now let's look at movie B. We're going to go to our graph. So this is the ordered pair we were given. It's saying in 4 days, it made $7 million. We know it's a proportional relationship because it starts at the origin. So no, we can say our ratio y to x is 7 over 4. When I do 7 over 4, we say right here, that's 7 over our 4. passes through the origin is proportional. 7 divided by 4, written as a decimal, is going to be 1.75. Again, this is in millions. So this represents my slope or constant rate of change, or my unit rate of movie B. So 1.75 million per day. So when I write that in million, 1,750,000 per day released. So therefore, the greatest amount of sales was movie A by $50,000. Now it's your turn. We have the Main Street Water Company that charges $3.67 per cubic foot of water used. They are asking us to assume that this is a proportional relationship, which makes sense. If you use 0 cubic feet of water, you're going to be charged $0. The table represents the amount charged for water usage by the Well Water Company. Which water company charges less and how much less, and be able to explain your work. So once again, Main Street Water Company is your first company. You were given it in words. And then your second is Well Water Company, and you've been given a table. So you have 2 different relationships, one in words, one in a table. I'm going to ask you to pause here, determine which one charges less, how much less, and be able to explain your work. Good luck. Welcome back. So here's our solution. Main Street Water Company charges $3.67 per cubic foot of water used. So that is our unit rate, our slope or constant rate of change. Then we go to our table, and I'm going to go straight to, because it's a proportional relationship, it passes through the origin, I'm going to go to when x is 1. That tells me my unit rate, $4.53 per cubic foot. So Well Water Company, $4.53 per cubic foot, because I'm looking for a denominator of 1, and our slope, or our constant rate of change, is a ratio of y over x. So when x is 1, there's my unit rate. So we can see that less is Main Street Water, $3.67, but I was also asked how much less. So we're going to take Well Water at $4.53, subtract the $3.67, we get 86 cents. So we can see that Main Street Water charges 86 cents per cubic foot less, and that's our answer. So I thank you for joining me today at the Magic of Math, where we continue to master math one video at a time, learning about proportional relationships and slope. I hope you have a great day and that you'll come back soon and hang out and learn more about slope.